How did algebraic notation evolve in math? Imagine trying to solve a puzzle with no clues or labels. That's how early mathematicians worked before they developed symbols to representing numbers and operations. Over time, they created a language that made solving equations much easier. In the beginning, algebra was written out in full sentences. For example, instead of writing x plus 1 is equal to 2, people would say the number plus 1 equals 2. This was called the rhetorical stage. Civilizations like the Babylonians used this method for many centuries. It worked for simple problems but got complicated quickly with larger or more complex equations. Then, around the 3rd century, mathematicians started using abbreviations and symbols. This phase is called syncopated algebra. Diophantus of Alexandria was a key figure here. He used symbols for unknowns and operations, making equations shorter and easier to work with. Still, it was not fully symbolic. It was a step toward the modern way we write math today. The real breakthrough came in the 15th and 16th centuries. Islamic mathematicians like Al-Khawarizmi and Omar Khayyam developed notation that used letters for unknowns and constants. They solved more complicated equations and created a bridge to the algebra we use now. Later, in the 16th century, François Viet introduced the systematic use of letters to stand for unknown quantities. This was a big change. In the 17th century, René Descartes refined this idea further. He used the letters X, Y, Z for unknowns and a B, C for known numbers. He also introduced the use of exponents and standard symbols for addition, subtraction, multiplication, and division. This made writing and solving equations much clearer and more organized. This evolution from writing problems in words to using symbols helped mathematicians handle more complex problems. It made solving multi-step equations easier because you could clearly see what to do at each step. For example, combining like terms, and doing operations, and isolating variables became straightforward. Thanks to these changes, algebra became a universal language. It allows us to express relationships between quantities simply and solve linear equations step by step. This progress made teaching algebra easier and learning it more accessible for everyone. In the end, the development of algebraic notation was a gradual process. It moved from full sentences to concise symbols, making complex problems manageable. This evolution is what allows us today to work efficiently with linear relationships and solve multi-step equations with confidence.